Hi guys, how are y'all doing? Welcome back to my second video. And in this video, I will be going over how to create a basic network scanner where I will scan for hosts, whether they are up or not, find their MAC addresses, and check a number of specified ports if they are open or not. So let's get into it. First of all, I will be using Python to write these scanners, and the library that I will be using is Scapy. Now, you might be asking, what is Scapy? Well, Scapy is just an open source library that allows the creation, sending, and capturing of network packets using Python. I will be using three methods for creating basic network scanner: ICMP Echo Requests, ARP Requests, and TCP Scan. I will be using ICMP Echo Requests, which is just a message that tests if a network device is reachable or not, to check if the hosts are up or down. Now I will get into writing the code and show you guys how these scanners can be made. Alright, so let's just get into writing the code. So I will be writing now the ICMP Echo request. So what you guys need to do is just go and open a text file. You might as well just save it right now. So I'm gonna choose desktop and I'm gonna name it icmp.py and save it. So here, let's start. We will start by importing the libraries from scapy.all. So what this line of code here does, it imports Scapy classes and functions. So these three right here are Scapy classes or functions, and they will help us use the functions that are currently built to create the packets and like do the stuff for this scanner. ICMP here, this represents the ICMP protocol in Scapy, and it allows us to construct ICMP packets. The IP here represents the IP protocol in Scapy, and it is used to create and manipulate IP packets, including specifying the destination IP address. And SR1 is just a Scapy function that is used to send a single packet and wait for a response. Now let's define the function. So I will name it pingscan, and this function is going to take one argument, which is the target IP. So now now we created this function, so now we will have to write or create the ICMP packet itself. So I'm just going to name it ICMP packet is equal to so what this line of code here does is we are creating an IP packet with the destination set to our target host, and we are adding an ICMP header to this IP packet. Well, and this basically creates an echo request that will check if the host is up or not. Next, I will record the response. So what this line of code here does is SR1, we use this to send the packet that we created above, the ICMP packet here. So, and this timeout one means that we are going to wait only 1 second for that response to come. And verbose 0 is like not important, like it just makes sure that unnecessary output is not presented to us. So now we will check if there is a response. So if response, because if nothing is returned within this 1 second, then this response here will be null. Like there won't be none. So if there is a response, then we are just going to print the host is up, else the host is down. And now we can check if this program works or not by just running it. So I'm gonna call the function ping scan, and I'm going to give it an IP address, which is another device on my network. So if I save this, so I made sure to save it, and I go over here, I go to the desktop, and here you guys can see there is the ICMP.py. So I just need to go Python 3 dot icmp dot py. If I run this, I should see that my device is up. Okay, so as you guys can see, it says this host is up. Now you might be asking, well, how do we know that this host is actually there? Well, I can show you my Windows. I can go here, type cmd, and ipconfig. As you guys can see, it is the same device. So, I mean, just to check it, that it's actually working, I can change it to this IP address, and it's not going to work. It's going to say that the host is down. But just to show you guys, as you can see, the host is down because it's not even on my network. So this was how you can create an ICMP Echo Request network scanner to find whether a device in your network is up or not. Now I will be using ARP requests to discover devices, and for your information, an ARP is a communication protocol that discovers the link layer addresses or MAC addresses that is associated with an internet layer address or IPv4 address. So if I go here and open a new file, I will just name this uh, arp.py. So now first of all we always need to import the libraries from scapy.all. So what this does here, ARP allows us to create ARP packets, Ether allows us to create Ethernet frames which carry the ARP requests and replies, and SRP is a function that is used to send and receive packets on layer 2, which is the Ethernet layer. Now I will need to define the target IP. So the target, now if you guys don't know, this /24 means that we will scan hosts uh, from 10.22.1.1 until 10.22.1.254. So this is what this /24 at the end does. It will allow us to scan all 255 targets that are on a network. Now I will need to create the ARP packet. So the ARP packet. I'm specifying here the packet destination for each host. So what I've done here, I have created an Ethernet frame that has a broadcast destination address. This will allow us to send this Ether frame to all the devices in the network, since they all listen to broadcast addresses. Here I have just combined things together to form the full packet that will be sent to all the devices. What I've done here is this SRP here sends the complete packet and waits for a response, which is 3 seconds. Timeout, yeah, I just explained timeout. I've explained verbose that it's not like, it just helps us not see unnecessary output. And this iFace is 0. I'm just specifying the network interface to ensure that the packets are being sent on the correct one, because SRP doesn't always send them on the network interface that you might be on, so I specified it. And the result of this function is a list of sent and received packets. So this 0 here, it accesses the first element, which contains the responses. Now I will need to create a client list. This initializes an empty list called clients, and it will store information about the devices found during the scan. And now I need to process the results. So for sent, so this loop here goes through each response or each result and received from the ARP request. And for each response, we have this send packet and the received packet, or the reply, the ARP reply from the device. So what this then does here, it appends a dictionary to the client's list, where this receive.pcrc here is the IP address of the device that replied to the ARP request, and this here is the MAC address of the device. So now we need to print the results. So here I've printed the results, and we will now test this scanner. So we can just now run this. And see the results. And yeah, here we go. We have this device, which is the Windows that I've showed you before. It grabbed the MAC address, and this is the router IP, and it also grabbed the IP address of the router. So yeah, this is how you guys can use ARP requests to find the MAC addresses that are associated with the IPv4 addresses of the devices in your network. Finally, I will be using TCP to find ports that are available or on the hosts that we find or that we choose to scan. So first of all, we will need to create a new file, and I will name this just tcp.py. So here again, we will need to import the libraries. Now we will need to define a function. I will name it TCP scan, which take two arguments: the target IP and a ports list, or yeah, a ports list. Now I will loop through the ports. I will create the SYN packet. So and this can be done through combining the IP function with the TCP function. So what this line here does, so we are creating an IP packet, and we set the destination IP address to target IP, and we create a TCP packet here with this with the port. So the port that it's in our list will be the destination port for the scan, and this flag equals as here. This sets the SYN flag in the TCP packet. So this is a SYN packet, or synchronization request, which is the first step in establishing a TCP connection, or the three-way handshake. When scanning ports, this is used to probe the port without completing the full handshake. So now we will need to uh, send the SYN packet and wait for the response. So this response will either be a SYN ACK or packet, which means that the port is open, an air st ACK, which is if the packet, which is when the port is closed, or not a response, which means that the host is unreachable. Now we need to analyze the response. So if if there is a response and the response has layer TCP, so what this line here does is So this response TCP flag is equal to 0x12. So this checks if the flag field of the received TCP packet is this value. And in TCP, a flag that is valued with this means SYN-ACK. So it was acknowledged. There is a synchronization and acknowledged came back. But now I will handle the case where there is no acknowledgement, so the port is closed, not opened. And this here means that the port is closed. And now I have to handle the no response. Or when the host is unreachable. Now let's test our program by writing or calling the functions. So first of all, I will define the target IP, which is uh, this right here, 10.22.1.111. I will declare the list with the ports that we want to scan. So 22, 53, 80, 443, 3306. And you guys can add more ports if you want. And now I'm just gonna call the function with this target IP and these ports to scan. And let's see the results. Okay, so I'm missing this one here. I was missing an S here. And the other issue is... Oh, great, there is no more issues. So as you guys can see, all of these ports are closed. So now I will open one on my Windows machine. So I can just go here to the command prompt. I can go python/m http.server on port 80. And this will create an HTTP server using Python on port 80, which is one of the ports here that is closed. So as you can see now, it is serving the HTTP server. So now if I scan again, as you guys can see, the port 80 is now open on this device. And yeah, this was everything I had for this project. Thank you guys for watching this video, and I really appreciate it. If you guys have any questions, please let me know down below, and I wish you guys have an amazing day. Bye bye.